Today on the deep dive, we are tackling a problem that anyone who loves high-end tech has probably run into: physics.
It's the ultimate buzzkill, isn't it?
We've got a stack of specs here for the NTI fiber optic extender, specifically the model with the incredibly catchy name FIBER-S-LCLC-50G-50M-PLNM.
Rolls right off the tongue.
And our mission today is pretty wild, taking a massive 8K video signal and pushing it, well, the length of 3 football fields.
Which, if you've ever tried to run a standard video cable more than a few yards, should be totally impossible.
Right, so set the stage for us.
Yeah.
Why can't I just buy a really, really long DisplayPort cable and run it from a server room to a display 300 meters away?
Because copper just has a limit. It's called attenuation. The electrical signal, it meets resistance in the wire, and the data just sort of evaporates.
And for high bandwidth stuff like 8K,
a standard copper cable starts choking after about, 15 feet?
15 feet, versus the 984 feet or 300 meters that this NTI system claims. That's a huge gap.
It is. And the only way to bridge it is to stop using electricity and start using light. This system uses a local unit.
That's the transmitter.
Right. And a remote unit, the receiver, to convert those electrical signals into optical ones.
I did notice in the notes it mentions a very specific type of cable connecting them. 12-strand multimode OM3. That sounds expensive.
Well, think of OM3 as a multi-lane highway designed for light. It lets you get massive data throughput. But the real key here, and it's in the fine print, is the MPO Type B spec.
Is that just the shape of the connector?
It's more than that. It's about polarity. It makes sure the fiber strand sending light on one end matches the strand receiving it on the other.
What happens if you get it wrong?
If you get Type A by mistake, it's like driving on the wrong side of the road. The signal just crashes. No picture.
Okay, so we've got the highway. Now let's talk about the traffic on it. We're trying to move 8K resolution. That's, 33 million pixels?
33 million pixels at 30 frames per second, yes. Or you could do 4K at 60 frames.
And the bandwidth for that is?
Nearly 24 gigabits per second. It is some serious heavy lifting.
And the system supports DisplayPort 1.4 features, right?
Yeah.
So we aren't losing the cool stuff like HDR deep color.
Exactly. You get the full 36-bit color depth. But there is a catch.
There's always a catch.
The weak link in these setups is often the short copper cable you use to plug the computer into the transmitter.
The last few feet.
The specs are very clear on this. If you want that full 8K experience, you can't just use a generic cable. You need NTI's specific DP14 series cables.
So if I use a cheap cable for that last little bit, I could bottleneck the entire 300-meter run.
You might find yourself capped at 4K, wondering why your very expensive system isn't working as advertised. It's a classic mistake.
Now, beyond just distance, why go through all the hassle of fiber? Is it just about the reach?
It's also about protection. Copper cables are basically long antennas.
Okay.
They love to pick up electromagnetic interference from, fluorescent lights, heavy machinery, medical equipment.
So if I'm running this in a factory or a hospital, a copper wire might just give me a fuzzy picture.
Or the screen could just black out completely. Fiber is glass. It's totally immune to all that electrical noise. Plus, this specific setup is Plenum rated.
I see that term a lot in building codes. Plenum. What's that about?
It just means the cable jacket is fire resistant and won't release toxic fumes, so you can run it through the spaces above suspended ceilings where the air circulates. It's a safety thing.
Speaking of fitting things into tight spaces, I was actually surprised by the physical size of the hardware.
They are incredibly compact, aren't they? Both units are just under 3 inches wide. And they're really efficient. They only consume about 3 watts of power each.
That's nothing. Now, for the IT crowd listening, there were a few acronyms in the feature list.
Yeah.
TAA, MST, and AD. Can we go those real quick?
Sure. TAA compliance is huge for government or military contracts. It basically just means the product is made in a compliant, friendly country. Supply chain security.
And MST and EDIDE.
MST is multi-stream transport. It lets you daisy chain monitors, which is a nice feature. But EDIDE is the real MVP here.
Extended display identification data. That's a mouthful.
It is, but what it does is it's a digital handshake. It makes sure your computer knows exactly what kind of monitor is 300 meters away, so it sends the right resolution automatically.
So you don't have to fight with the settings?
You don't have to do anything. It just works. It makes that huge distance feel completely invisible to the hardware.
Which means we're looking at a future where the computer doesn't need to be anywhere near the screen.
Correct. We're decoupling the processing power from the visual interface.
Which leaves me with a final thought for everyone listening. We usually think of fiber optics as this big infrastructural thing, for the internet. running under the ocean.
Mm-hmm.
But as our screens get higher and higher resolution, 8K, 10K, beyond, will we reach a point where even the copper HDMI cable in your living room is just obsolete? Will we eventually need lasers just to connect a game console to the TV 5 feet away?
If the bandwidth keeps climbing at this rate, we just might.
Thanks for diving in with us. We'll catch you on the next one.